So please do watch it and enjoy learning physics.
Hi, in this video I'll explain about the concept of ray diagrams for a convex lens taking the object in 5 different positions. So firstly, we look at the convex lens itself. It's a double convex lens. It's bulged on both sides and you can see a vertical kind of bonding in between as if two shallow glass dishes have been stuck together. So we'll put a light source on the left hand side and we will draw a principal axis through the center of the lens, as you can see the white line, and put in the points f1, which is the focal length, as you can see, and 2f1, which is double of the focal length. It's the same thing we do on the right hand side of the lens. We draw f2 and 2f2. The intersection of the white line, which is the principal axis, and the vertical line through the center of the lens is the absolute center of the lens, is marked as O. Let's take an object at a simple position, 2f1. We draw 3 rays. The green ray parallel to the principal axis, it will refract, bend and pass through the focal point f2. The red ray, which passes through the center of the lens, will not change its direction and will go the way it came. The blue line will pass through the focal point f1 and it will become parallel to the principal axis. The blue ray behaves in fact opposite to the green ray, as you can see. Now the image is formed by the meeting of these 3 lines. The 3 things are, it's inverted, it's real because real rays are meeting there, and it's of the same size as the object. So always we talk about 3 things for an image, and if we can describe the image in its 3 parameters, we would be on top of a ray diagram. Now let's move the object a little far away from the lens. The light source is still on the left, so a point to remember is the rays of light will always move from left to right. They will never travel from right to left. So now the object is stabilized and we do the same thing that we did before. We draw a green ray parallel to the principal axis, another colored ray passing through the center of the lens, and a blue ray passing through f1. So they will behave as they behaved before. The green ray passes through f2, the orange ray continues, and blue ray becomes parallel to the principal axis, and they're all meeting at a point. An image is formed. And the 3 things about this image are: 1, it's inverted. The second, it's real because real rays are meeting there. And the third point is that it's diminished in size. I just want to remind once again that the 3 colors of rays are just for the purpose of remembering the ray diagram and for the purpose of explanation. The light source being a white light source, all the rays of light are in reality white in color. Now let's move the object to another position between f1 and 2f1. This is an important position and I'll tell you why. So the object is now stabilized in its position. We'll do the same thing as we did before. The green ray parallel to the principal axis, the orange ray through the center, and the blue ray through f1. You can now guess what's going to happen. So the rays will travel till they all meet, and they seem to be going on and traveling a pretty long way before they meet, which indicates that we are going to get a large image. The image is really large, and you can see the 3 things about this image. Number 1, it's inverted. Number 2, it's real because real rays are meeting there. And the third thing is that it's enlarged or magnified. This magnification obviously is useful in a compound microscope, and if you get a question on a compound microscope, you will probably have to draw this ray diagram. And of course, a compound microscope uses more than one convex lens. Next, let's put the arrow very close to the lens. Now, as I said, the rays of light can't travel backwards, so you won't get a third ray or a blue ray traveling through f1. We just draw 2 rays and complete the ray diagram. The first ray will be the green one, parallel to the principal axis. The second ray will be the one passing through the center of the lens. Now here, even as they travel, you can make out that they are diverging. So the image will not be formed on the right hand side. So to form an image, we'll have to project them backwards using dotted lines to create an image. And the green dotted line and the orange dotted line meet at a point, which is good. So you get a arrow there colored in pink, and the three things about this arrow are: number one, it's erect, it's not inverted; secondly, it's virtual because dotted lines are meeting there; and third thing is it's enlarged or magnified. So that was a description of how we can draw ray diagrams successfully. Let's take another position which is exactly on F1. Obviously there won't be a third ray passing through F1, so we have to draw only two rays. So we do the same thing: the green ray parallel to the principal axis, the orange ray through the center of the lens. Here we see that they are parallel. So even if we draw dotted lines behind them, we will never be able to make them meet. That means that there won't be any image. For a convex lens with an object on the focal point, there is no image. So that's all there is to a ray diagram for a convex lens, and I hope this video was useful to you and that you found it simple and easy to remember. Thank you and have a great day.